Thank you, Aline, for the invitation to present here today. It's a pleasure to join Marcel and Dana to give this overview of the work that has been done by the IEA Hydropower and Fish task. And I suppose that my role here today is just to give a short introduction and a history of the International Energy Agency for this hydropower and fish work group since I joined the group since the inception, and that's what I will try to give an overview and then pass it over to Marcel and to Dana. So as Aline said, I'm a senior researcher here at ETH, working at the Institute of Environmental Engineering, and I currently lead an eco-hydraulics research group focusing on hydropower impacts as well and mitigation within the Stocker Lab at ETH and IFU. So to move on without any other ado, the IEA Hydro and Fish task started actually a while ago, and I was, a few years younger and a few kilos lighter as well. But back then, during that time, we had a group of people that was back in 2013. We met at the National University of Laos, and we had particularly a small group of people that involved myself and other colleagues from the US and Australia that were working around a similar topic. And we took the opportunity at this meeting in Laos to join then the executive secretariat, Niels Nielsen at the time, for the IEA, colleagues from EDF France, from Hydro Tasmania in Australia, from PNNL in the US, and New South Wales Department of Fisheries in Australia, to discuss common interests and common issues around hydropower impacts. And from that meeting, this group kind of formed a smaller group that included myself at the time working in Brazil with my colleague André Castro, Richard Brown and Daniel Deng at PNNL, and Lee Baumgarten, Craig Boyce at Charles Sturt University and New South Wales Fisheries, to focus the work mainly on the issue of fish turbine passage that would then refer back and be critical for dam development in Laos, given the high head dams and the large dams that were planned to be constructed over there. And we were all at these different countries and different places working on the same issue, which was around biotrauma research. So we were focusing on trying to understand the effects of pressure changes that the fish goes through the turbines in our work. And one of the first outcomes that we had from this short group getting together was this publication, which is basically a perspective around hydropower or biotrauma in fish passing through hydropower plants around the globe. And we then came up with a framework. We indicated some knowledge gaps associated with the need to diversify species that we were going to study, understand buoyancy, and so on. And we pushed forward with a series of experiments that I'm not going to go through all of the results, but this is just to show how the idea around forming this group for the IEA started, and then Marcel will tell how it grew ultimately. But I had a master's student that went to PNNL and ran a series of experiments with a pressure chamber that was already built and operating at PNNL at that time. He used an Amazonian fish species, Pimelodus pictus, to test, and those were the first results that we obtained with a new tropical species, or basically a species that was outside of temperate regions. So we were working, and that was the first work with tropical fishes. And we started to see some interesting results. I'm not going to go through details here, that some of the injuries associated with biotrauma in tropical fishes, they were occurring at much lower ratio of pressure changes that could occur in turbines, for example. And that was quite interesting. And in Brazil, we had a similar pressure chamber And then with colleagues from the University of Southampton, we pushed the work forward there as well and tested another 2 species from tropical systems. And we saw a similar pattern that the risk of injuries for the 2 species, one is in light gray, the other one's in dark gray, was increasing and very much related to the ratial pressure change or a smaller ratial pressure change for them to occur. Then in Australia, there were similar experiments happening, and there, because of this knowledge that we kind of developed, we managed to come up with this pressure chamber as well that actually simulated pumped hydro passage for fish, where with another shear flume stress, we combined or tried to assess the combined effects of both shear strain and pressure as fish would move through a turbine, simulating shear and pressure changes that they would encounter in the turbines. And we tested multiple life stages and got some interesting results, such as compression for fish. If the fish is compressed when they move through a turbine, most of them will survive. But the shear strike is extremely dangerous to early life stages, to young fish, such as larvae and eggs. And as they grow and become bigger, then the shear stress is not so much of a critical issue for them at that stage. So this is a bit of a summary of some of the results we got. And since the inception of the IEA Hydro and how this smaller group moved on with this biotrauma work, SINTEF with previously Dr. Hans-Peter Feldstad led the task, the hydropower and fish task, and grew that fish task to incorporate several other partners and extend on a variety of topics that would be pretty much all focused on all of the potential impacts of hydropower on fish. And that group continued to move forward. And one of the things that we strive to do is to find ways to indeed pursue collaborations between international partners on the very same issues that affect fish and hydropower across the globe. And that's how we maintain the group operating. And then Marcell will now give you more information about the details of how the IEA Hydro and Fish task was managed by SINTEF since he became the lead agent in the process. So with that, I thank you very much, and I pass it over to Marcell.
Thank you. Welcome, everybody. And I also would like to start my talk with a thank to Aline to coordinating this seminar and inviting us to present this work together with Luiz and Dana, because it indeed, as Luiz already presented, compiled such a valuable knowledge gathered over more than a decade, actually. But we will see that through the slides and presented in the next few minutes. The next slide, please. Thank you. So, as Luiz mentioned, since 2013, basically, the IEA Hydro has dedicated a working program on hydropower and fish, just to raise awareness and provide better understanding of the effect of hydropower on fish. And in the closing phase of this program, the aim was to compile and transfer such knowledge that has been disseminated through papers, seminars, workshops, field trips, and so on. Basically, provide a roadmap to the public. This roadmap that was planned to address these emerging best practices. If you can click just one more, please. Perfect, thank you. So this roadmap was planned to address emerging best practices that meet its objectives, basically to provide mitigation measures for fish at hydropower plants in order to minimize the impact of hydropower activities on the fish communities and their habitats. Not only, that is fine. So fundamentally, the roadmap may lead the reader to the best practices in identifying challenges, solutions, and the decision-making process to achieve the objectives. As you can see, the work was indeed based on an international collaboration of experts that represent several disciplines, institutes, and different countries. As you can see, several researchers from around the world contributed to the content. They are presented on the left side, while almost the same number of people elevated the quality of the final document as reviewers. The next slide, please. The compiled information is incorporated the technical and ecological experience from the beginning of the modern hydropower utilization. Per se, the roadmap consists several sections that in the next few slides I will introduce briefly. Overall, the document is intended to serve as a knowledge basis on a holistic level to achieve sustainable hydropower development on a river basin scale. Next one, please. The introduction and background outlines the objective of the document, as well as its scope, purpose, and structure. Then it presents the main aspects that are discussed, such as the role of hydropower in modern times and the importance of riverine ecosystems. It is also emphasized that the sustainable hydropower is set by legislative actions that limit the impact of hydropower on selected fishes or their habitats that could be identified as target species or targeted aims and part of the overall ecological aim. Good examples on such legislative actions are presented in this part of the document, while recommendations to develop standards are also provided to those regions where such legislations are outdated or not yet well developed. Thank you. Next, the core of the document starts with the problems and solutions that discuss the main challenges on inland water courses by planned and existing hydropower regulations. First, it describes these challenges that are identified as issues that are certainly occur, or risks that may occur. It presented through the processes that frame issues and risks on the regulated water bodies, such as the effect of fragmentation. This is in the main focus of the roadmap, fragmentation, but also through artificial inundation, the disturbed sediment transport, water temperature and water quality changes, as well as water regulation and water abstraction. In the next, the roadmap addresses these issues and risks one by one and describes nearly 100 different types of measures. And in all cases, they are supplemented by information on recommendations and possible limitations to remediation. Next, please. As I mentioned, the main focus of the roadmap was on the fragmentation issues. It is well known and historically well documented how the people and together with the modern hydropower utilization try to mitigate the issues for upstream migrant fish. Yes, that is correct. Although these measures and these solutions are not always suitable for all fish species that may differ from, or not may, that is certainly differ from regions to regions, as we have several ecological so-called ecoregions through the world. Since it's become a hot topic, alongside with the upstream alongside with the mitigation measures for upstream migrant fish, that has been also dedicated an increasing dedication towards downstream migration solutions. Here, we collected 35 different measure types that are described, some in very detailed, but in all cases provided with some further knowledge and some anchor points in publicly available literature towards the reader who is interested to search in the technical or operational details in among these measures. Next one, please. Just giving a short example. Yes, we took just some illustrations and nice slides, nice pictures from the reality, how it could look like. But then we went into the detail to describing what is the main aim of the individual measures. In this case, of course, just to talk about the conceptualization of a vertical slot fishway, how it's designed, how it operates, when it's suitable to different kind of fish, and for what kind of hydropower utilization for the given head size and so on, it may be suitable. Next one, please. But beside of the well-known technical solutions, we also wanted to promote, of course, the best practices wherever it's possible. And one of its example for best practices is the bypass fishway, or the nature-like bypass fishway, to be more precise in technical terms. These solutions, of course, wherever it's possible, is more suitable for vast amount of different fish species that are migrating or aim to migrate towards upstream sections. They can also serve as habitats, as we already see from some studies and documented cases. But beside of this, beside from the upstream, beside of the upstream solutions, we need to and wanted to promote the emerging new practices and testing and solutions under testing for downstream migrants as well, such as, for example, as presented, the barrier nets that blocks the way from the entire reservoir and that blocks the way of the fish that entering from the reservoir through a dedicated safe bypass to actually pass through the dam structure or alike barriers, or the inclined wrecks that serves as, or that basically acts as a physical barrier that hold the fish migration towards to the intake channels, and the different kinds of curved and modified bar racks that could be placed also in intake channel to guide out the fish from the intake channel towards the dedicated safe bypass. And lastly, just in this presentation, the electrified wires to use as a hybrid solution where generated electrical fields, really mild fields, just to introduce reaction, or not introduce, but to trigger some reaction from the migrant fish and guide them, while in the same time through such wires as presented to the other, or in comparison to the other measures, introduce much less head loss, for example, that is beneficial from operational point of view. Next slide, please. All the knowledge that are concluded here and through the roadmap are translated in different formats, of course, focusing on the fragmentation. For example, we provided a tabular overview of the different measures, providing such key findings from these measures. For example, for the upstream migrants, the general applications, and the pros and cons of the different measures that is presented one part of this overview on the left side, one on the right side. Something similar is also presented for the downstream migration measures. Next one, please. Yeah, so the core part of the roadmap is more than just describing these problems and solutions, and via solutions, I mean the measures. It is also intended to assist the readers between the different alternatives through the developed flowcharts, and this is what the decision support tool is about. So first, it helps the reader to identify relevant challenges through simple questions, then to narrow down on what type of measures they might select from. So meaning if you have a hydropower project in head or a hydropower layout in head, answering some simple questions about the layout, about the ecological surroundings and the target fish species, you're able to navigate and narrow down what type of problems you might face with. And the next, you also provided through, please go back to the decision support, thank you. You are also guided as a user towards relevant solutions. However, it is emphasized that the final selection should be taken in all cases with local experts supported by detailed on-site studies, ecological and technical as well. If you, yeah, thank you. Okay, towards the end of the document, actually the final part of the document, the roadmap provides an overview of the different monitoring techniques that are and they are described for necessarily and adequately design, adopt, and operate the mitigation measures on site. It also summarizes the different kind of monitoring programs that are able to characterize either the aquatic environment, fish movement, or their abundance on a given spatial and temporal scale. Beyond fish passage assessment, as it was also in the focus of the fish monitoring of the monitoring chapter, focusing on following the focus on fragmentation. It also discusses different techniques for habitat evaluations. Thank you. Next one. Just summarizing basically at the end what this roadmap is about. As we saw, it starts with a broad background of hydropower and fish. And it basically concludes the conflicts between hydro and fish. When there are challenges, numerous solutions are described as mitigation measures for further considerations. And together with the flow charts, this roadmap is intended to help the reader in order to navigate between the previously mentioned nearly 100 different measures. It has to be noted that although fish populations were in the main focus of the presented work from ecological point of view, many of the described tools may also be beneficial for viable habitats and other aquatic species as well. The roadmap is openly available. You may download it via the QR code if you haven't encountered it yet, because we are really happy to see that since it was published officially more than a year ago, almost 2 years ago, and that it really gained a lot of interest and has been highlighted from different European countries and on a global scale as well, with more than or around 1,000 downloads and many views as well. Feel free to access it if you haven't done it already, or disseminate it within your network as you like. With that, I conclude and end the part about the roadmap. Next, in the few more minutes, what I have, I would like to talk about the future of hydropower and fish working program within IEA Hydro. So the roadmap finished the first phase, basically, the hydropower and fish working program. But the work did not stop there. During the construction and writing, editing of this roadmap, we realized there are some topics that we intend to follow up and intend to put as a main objective for the next phase of hydropower and fish working program within IEA Hydro. So with that, we propose that to the working group together with a new program and a new follow-up task of hydropower and fish within IEA Hydro. This is the Hydropower and Fish 2.0. We were not that creative with entitling this program, but anyway, you get the point. There are many countries also involved, as you can see, representative from Switzerland, as for example, through Luiz as well, but many other countries are also involved. Next, please. And with that, I just want to highlight one by one that what were these main objectives, starting with the environmental flows, where, as you can see, some applied methods on local and regional scale, including and introducing trade-offs between ecology and power generations, we intend to put in the main focus of this following program. Next, the utilizing advanced techniques for monitoring based on data abundancy for enhanced knowledge in order to gain basically more and more information, filling the gaps and the knowledge gaps basically for fish and their habitats, understanding them better. And finally, the risk assessment for hydropower operation and fish, basically with all the gained information, what we theoretically able to gather through the modern techniques, whether it's from the field or through lab or numerical investigations and models. It could be already used on a local scale, regional scale, or let's see if something could be standardized out from it. But the importance of such information is emphasized towards mitigating better, towards making the hydropower indeed sustainable, and towards making it sustainable. With that, I think I stop here. Thank you for your attention. If there will be any questions at the end of our module, I'm more than happy to answer it. And I also ask Dana to please follow.
Thank you.
Continue. Thank you.
Yeah, thanks so much, Aline, for setting this up, and Luiz and Marcell for this great introduction. I am Dana McCoskey. I'm coming to you from the United States, from Washington, D.C., from the U.S. Department of Energy's Water Power Technologies Office. And we are the innovation branch of the government, and we work to fund science, research, and development. And I first became aware of this IEA hydro work from working with Pacific Northwest National Lab, and some of Luiz's students were there. Some of the tools that we were developing that DOE was funding, like sensor fish, were being used all over the world. And I had some experiences where I was in Laos, and I met some of the groups that were being funded by the State Department to work on the Mekong River with the Commission. And then Marcell, when we formed a partnership with the Norwegian Research Institute's Memorandum of Understanding, which is different than the IEA work, but lots of overlap between people. And I recently, in April, became the US rep for the IEA. And I just wanted to say this is only one of the topics that we work on. We have the ability to form different tasks as long as there are two countries that want to collaborate. But we see with hydropower and fish a broad interest from many countries, and there's many topics that people are still trying to solve as we're trying to figure out, like the climate crisis, how to design infrastructure to support nature. And so we keep talking about these things and working slowly towards solutions. And so what I'm going to first do is give you an orientation to where I'm coming from, since we have a lot of EU people here and maybe even broader international on the call. And then I'm going to talk a little bit about what we're doing at DOE to support implementation of research and science into practice. And I have a couple of case studies. And then we'll go back to the IEA work and we'll talk a little bit about the different tasks in Task 19 that Marcell overviewed at the end of his presentation. So let's go on to the next slide. To start, I have a few maps here. I wish I had an international map for this group, but I think probably anyone who's joined this call is well aware that hydropower is an important part of meeting the climate goals, and it poses a lot of challenges. With hydropower and fish, Marcell went over some of the key topics that we're continuing working to improve. But in the US, we have over 2,000 hydropower dams, over 90,000 dams total. So just a small subset of them produce power. It's an aging fleet. We have to get permits to operate, and that's when the environmental reviews take place. And we have a lot of diversity of fish species and a lot of differences between the regions in climate, biodiversity, and power needs. And so what we're experiencing right now is, for one, increased power needs, especially with the data center and some of the processing that's being built out. But also the solar and wind is being built throughout the country at a rapid rate. And so we're seeing changes of generation capacity and needs for our grid. And so broadly at the DOE, we're working on all of these things, but in water power, we focus primarily on hydropower and marine energy. All right, let's have the next slide. So at the highest level, DOE has mission space in energy, science, innovation, nuclear safety and security, and also infrastructure. When we received the $62 billion from the bipartisan infrastructure law a few years ago, we had another pillar and we did a reorganization. So very large organization, lots of different things going on. Next slide. And within my office, we're going to focus on hydropower. We've been operating on around $59 million per year in appropriations. That's money that Congress gives to us to invest in R&D. We have a very large marine energy program as well. And we're talking about waves, tides, and currents, not offshore wind here. There is a whole other wind office that does that. All right, and so next slide. I've been putting this in here. We're working at water power on all scales. This can create a lot of conversations and sometimes conflicts when you're talking about dams, the value of small dams versus large dams. And so I did want to just put this here because across the board for both marine energy and hydropower, we're thinking about the value of that power and the capabilities from very small applications, maybe distributed, to very large, like how can we improve existing dams? In the US, we don't anticipate there being large dams built. We've put our infrastructure on the most beneficial to power production sites, and that's the landscape that we've inherited from the past generations. Next slide. So specifically about Water Power Technologies Office, we're supporting foundational R&D. We're working with a pipeline of solvers. Those are people that may be very prepared to do traditional R&D, like larger companies or universities, to people that have ideas that are trying to just, figure out proof of concept and see if they could make a business. We're providing access to infrastructure. We support demonstrations. We can do environmental assessments. We work to address regulatory barriers, which this topic of risk and mitigation is very related to. We try to provide science and information that helps people make decisions, not tell them what kind of decision to make. And we partner with communities and do a lot of outreach and engagement. Next slide. So what we have here is a bunch of different types of funding that we do and where we see it applying by research stage. And so we fund the labs for some of the earlier stage prototyping, even into demonstration. We have prizes, which is crowdsourcing innovation. We have these SBR, STTR, these are small business programs. We do technical support, we form partnerships with other agencies, and we do traditional R&D funding, which previously they were calling them funding opportunity announcements, and now I think NOFOs, notice of funding opportunity. So we have all these different tools in our toolkit to assess challenges and say, you know, like, what is it that we think is going to solve this challenge, and how can we stage things from like the lab to getting small businesses to take them, to crowdsourcing ideas, to just really staging like really traditional R&D. All right, next slide. And here's just a breakdown of our program areas. I put the star by environmental and hydrologic system science and the hydropower program because this is where I'm working. And so I thought, because the hydropower and fish work falls in here, let's talk a little bit more about it. Next slide. Okay, so within our previous 5-year plan that we're in the process of revising, everything on the left of this slide is really what we would consider like the environmental R&D. It's primarily focused on improving the environmental performance of existing hydropower, but also potentially informing, if there were to be new developments, how you would go about that in a very low impact and sustainable manner, and what types of information tools are available. So the monitoring technologies, the mitigation, and the environmental metrics are focus areas. And so you can see right here, there's a lot of alignment to this IEA work, which is why we've supported the labs and others participating in it. And it is really fish-centric, although we also do other environmental work with water quality and other processes. And we have this whole climate change program as well that, you know, we're just going to glaze over right now. Yeah, anyway. So yeah, next slide. Thanks, Luiz. So I just wanted to talk about just kind of where we're getting data and who our partners are, and how we kind of stitch together these things with a couple case studies. We work with some information that was collected from funding that was provided to EPRI from Ontario Power. So we had existing data that was collected to understand if we could detect eels migrating with sonar. In a very large system in Canada at the US border, there are quite a few dams, including the Moses Saunders Dam and the Iroquois Dam. And so we had some existing data. And so EPRI was in charge of this data, and they were able to compete on one of our traditional funding opportunities. And they partnered with Pacific Northwest National Lab, which has you know, a lot of diverse talent there, and they had a bunch of computer scientists that were able to take that data and develop a machine learning convolutional neural network approach to detecting and classifying eel. And they published some open source code and journal articles. They were able to use Pacific Northwest National Lab. You can see the picture of the flume to collect more data, to run tests, to improve this model. So we went in with some data, we collected some more data, and we had a software package that's available now that is pretty good at identifying eel in this type of environment, which is a very high flow environment. After that award was done, Pacific Northwest National Lab, because we had open source products, was able to partner through a commercialization funding program that we have at DOE to expand this type of process to other types of sonar, and they're in the process of publishing final results. So this is just one example of how we had some data that was collected from an outside source that we're able to leverage, and we're trying to look broadly, like, can we develop these types of systems that can enable real-time detection classification, and, you know, what will it take to integrate this into the fleet? So that's an ongoing challenge that we're working through, but we know we can do it. The next case study is about turbine design passage. Luiz talked a little bit about this because they did a lot of the barotrauma studies, which we refer to as like stressor response or dose response relationships. So back in the day, before our program was what it was, there was the Advanced Hydropower or Hydroturbine program, which was at DOE before we had the Water Power Technologies Office. And this really laid the groundwork that resulted in the Alden turbine, the minimum gap runner turbine, a variety of aeration turbines. You can see this picture of one of the turbines that went into the Columbia River on the right and the barotrauma chamber at Pinanel. So we leveraged this historic program that developed whatever you want to call them, fish-friendly, environmentally improved, but turbines that take into consideration the things that harm fish to inform the design of the turbine. And what we did with that is we saw there was still needs to understand the relationships with different types of fish, different types of stressors, and maybe focus on other turbines besides these propeller type Kaplan turbines. And so we were able to fund the labs to develop sensor fish and the Hydropower biological evaluation toolkit software, so you can use the sensor fish. We did a lot of science in the lab, developed these data sets, and we developed the biological performance assessment software, which allows you to relate numerical modeling to those dose response relationships. Just like sensor fish is a tool that you can deploy in the field, and it will pass through a dam or over a spillway, and it relates it to those dose response relationships as well. We've seen others take this science and go from there. Natel Energy has a design for what they call a fish safe turbine. Very high survival rates of fish that pass through their designs. And so we're working with them we were able to fund them as a industry performer to develop these turbines that fit a very specific market and could be widely applicable to a great amount of fleet and also in Europe as well. Like we were seeing them deployed. And so we worked with them, and we're providing ongoing technical support to help support industry in adopting the technology. So lab funding, the traditional R&D funding to industry, a lot of different types of projects within this theme are enabling us to translate this research into deployed technology that has environmental benefits to the fish. All right, next slide. So fish survival studies and tracking, this is a big one. Unfortunately, this is a blurry picture, but we have a variety of these different JSATS fish tags. The original one was funded with us in the Army Corps, and it's really led to a suite of different tools, both getting smaller, and one that we call the self-powered tag, which uses fish kinetic movements to send a signal as opposed to having a battery, which is in development, and the lab on a fish that has a bunch of sensors. We think of it like a Fitbit for fish. So we've worked with so many different partners over the years to support the demonstrations of these tags. So we get to the prototype stage, and then we need to figure out if they work in these really noisy environments or specific types of environments around dams. And so we've had like just tremendous support from industry partners that have let us take these tags in the field, that have helped us collect fish, like the State Fish and Game and others that, more than are even on the slide, to get the fish, tag the fish, do specific studies that we provide to the power companies that can inform siting of fishways, survival through turbines, and other types of things. So we found this is a really mutually beneficial way for our labs to get data to inform the development of the tool. Like, does it work? Does more optimization need to go on? Like, how long does it last? To answer all the questions that people have. And we've worked to enable these type of studies to be planned in HBET, the Hydropower Biological Evaluation Toolkit. And we've found ways to utilize other funding that's reserved for DOE for commercialization to transfer these to the private sector. So a lot of these tags you can buy now. ATS, Low Tech, others have licensed the IP for a nominal fee from Pacific Northwest National Lab. So this is one of the ways where we're working with the lab to develop technologies and finding industry partners to demonstrate them, and finding small businesses to take the IP and make these, manufacture them. All right, next study. eDNA, this is a big topic right now. The US now has a national strategy for aquatic DNA, which is marine and freshwater. So we're working to improve standards and to coordinate across the federal government. We started out by funding the lab to do some studies specific for applying eDNA to hydropower. They did some evaluations of fishways with eDNA and eRNA and working with freshwater mussel surveys. We also have a autonomous vehicle type EdnaBot project going on where there is some lab IP developed. The idea was developed at the lab, and we're working with commercial partners to try to make a cheaper, easier to use tool that hopefully, it's pretty early stage right now, but hopefully will be commercially available at some point, like maybe in a 5-year horizon if everything goes well. And so we're doing these studies to see how eDNA works that in a way that could replace traditional surveys. We're developing instruments at the lab that we think are going to be easy to use and commercially available. We're coordinating across like the space with our marine team and across the federal government. And we're also trying to implement this strategy for eDNA by working with the hydropower sector to understand specifically like what the challenges are to make it fit for purpose for the industry. All right, next slide. I always like to put a slide in here for STEM. We have all these fish tags. We've worked to develop programs. This is really led by Pacific Northwest National Lab and Benton Conservation District, but there's this large Salmon Summit project we do every year where we've brought our scientists into the classrooms to develop curriculum. We're tagging fish with these kids, we're releasing them, we're teaching their teachers how to understand the data coming out of our federal power system so that they can understand the outcomes of the fish migration. And so we're really going into the classroom and starting like at that stage. Like we want these students to grow up understanding fish life cycle, fish migration, fish life history, and to see real data so that they can answer questions about the outcomes of the fish through the hydro system. All right. And I just put this up here. I'm not going to go into detail, but this is a framework for showing like as you move down, you have increasing levels of engagement. And as you move up, you have increasing numbers of projects. We do lots of different types of things for communication. We're really hoping to be really involved or to collaborate when we're working with the International Energy Agency, like either through formal or informal partnerships. We want to be really involved and have information flowing both ways, and that information like translating into like group learning and process improvement. All right, next slide. And then taking it all the way back to the IEA Hydro TCP, Marcell did a really good job of outlining these different areas that are in the Hydro and Fish 2.0 or Task 19. I have this information about the overall participating countries. As the US rep, I can say, we're in a stage of active recruitment. We had some partners that have been lost over the years. I don't know all the backstory on it, but we see hydropower all over the world. And so we're trying to figure out who we should be working with on these different tasks. And with hydro and fish, we know that there's people all over the world that care about hydropower and fish and may have some unique contributions that they can provide to these different areas. So broadly, IEA Hydro is trying to recruit members from countries where maybe staff show up, but they aren't formally involved. And that will increase like our base revenue and our ability to do some of the work and strengthen our partnerships. So that's something that myself and the chair and the secretariat are working on amongst others, and we're coordinating with our agencies. So if you're interested, let me know. I can give you more information. But specifically for Task 19, go back one more. We are working on developing fact sheets, and that's the status we are like right now. Just what are we doing? Scoping out these projects, and there's a third one, but it isn't in the pretty format yet, so I didn't include the picture. But we're really at the project development stage. Like we've stated like what these 3 areas of interest are. We've identified a lot of people that want to work on them from our existing network. And we're moving into figuring out like what's next. Like what are we going to do? Are we going to publish papers? Are we going to try to do something else? I think that there is a lot of benefit to publications and reporting, but there's also something really important to be said about figuring out ways that we can work with people in the field or with the power companies to test out these ideas and to see if we can validate that like the pathway or the solution we've discovered may be able to be realized. All right, and I just have one more slide, and I think maybe my emails after this one, but these are the leads that are working on the fact sheets and are going to be scoping out these areas for Hydro and Fish 2.0. And so feel free to get in contact with them or myself. I think this will be recorded and we can obviously share our emails with everyone. But thank you so much for your attention. And it's really been my pleasure to speak to you all today. And I think we're all happy to take questions if time allows it.